I've got a brand new clean cell here. I pulled the coils out of the beaker, washed the beaker, refilled it with fresh tap water, and I have a thermometer stuck in it. And the thermometer right now is reading, as you can see, about right at 22 degrees C. And so I have a question to pose. When does electrolysis become the best? In cold water, in hot water, or does the water temperature make a difference so long as the area and the input energy is the same? And of course here we can't compare this really to Faraday's explanation of electrolysis because we're operating strictly in an AC mode. But let's take and explore this a little bit. Remembering we have 22C now, let's go ahead and start the cell up. Okay, I just punched the on button for the cell, and you can see there that we're starting to get some gas evolving from it. Now, one caveat I'll throw in here is if you're using the tie wire, the stainless steel tie wire that I use here, be aware of the fact that you do have to condition it. In other words, once you first wrap a set of coils, you're going to have to run that thing for maybe 5 or 6 hours for those coils to actually become conditioned. It burns, I believe, I'm not a metallurgist, but I believe it's burning all the oil and other impurities that are on the surface off. And so you can go ahead and condition your coils, and then you'll get your maximum efficiency out of it. But what we're operating here right now is we're operating at 20 volts, 76 mils, 1.4 watts. You calculate that out, it's a little different because of the way the supply displays its numbers. It rounds off. So anyway, we're building up some gas here now without a problem, and what we'll do is let it run for a few minutes, and then I'll just save the tape and come back to it, and we'll check the temperature and the energy input and go on with the explanation. Okay, this has been running for a while now, so I think it's pretty much stabilized, and it dropped down to 70 mils, 20 volts, 1.4 watts. And our temperature is running exactly still at 22C. So what I'm going to do here, I'm going to take an ice cube. How about that? I'm going to drop that ice cube down in there. I want to try to get it moved around so that you can see what's going to be happening here. What's going to happen? Come on. Cooperate with me, will you? Yeah, it'll probably settle down here in a second. This action, what you're going to notice, or I hope we can film it, is look at the gas moving over to the ice cube. And this ice cube is melting quite readily in here. You can see right underneath the cube here how the gas is accumulating. You can actually see how the cube is starting to get very shiny on the ends. Now normally we'd see some of this, in 22 degree water, but this cube will disintegrate probably twice as fast here in this beaker with the electrolysis going on than it would in normal. And we're down now to 15 degrees C in the water. We could stir it up a little, make it a little happier. But look at what's happened to that cube already. Can you see that? That cube is disintegrating readily in here. Those bubbles coming, the gas bubbles coming in here. There, maybe I can get it to where there. Now we can watch it. And what you want to see is what's actually happening. Look at the bubbles going over to the ice. See them all migrating towards the ice? Okay, if you're not, here's the area you want to look in. You see them migrating over through here, and you see the milkiness up here moving in the direction of the cube. But are you watching that cube too, how fast it's disintegrating? There's something going on here which I find quite amazing, is how fast this cube is disintegrating from these bubbles attacking it. That's the best way I can describe it, is that they're actually attacking it, and how the phenomenon necessary to melt this, I would assume, would be heat, but obviously it's not heat. We're down now to, let's see, 10, we're down to 12 Celsius now, and that ice cube is pretty much, well, it's almost gone already. Look at the bubbles around here, they just accumulate, and look at how it's disintegrating that ice cube. Now this is a plain fresh water out of the tap ice cube. There's nothing in this ice cube that would aid this phenomenon. But look at also our electrolysis. The amount of gas coming up here is visually different, and here we show that our current has dropped, but and we're showing 1.2 watts versus 1.4. So it would appear at first blush that this cold water, which is now 11 degrees C, actually allows the electrolysis to work much more efficiently than at 20 degrees C or 22 degrees C. You can see the ice cube's about gone now. And as you can tell, I haven't cut this video at all. So I can drop another cube in here, and well, again, it's not going to cooperate like it has in the past. It wants to float up there in front of the coil, which I don't like happening, but what can I say? That's an ice cube, and I'm me. So what can I do about it? Okay, so we'll watch this one for a few more minutes. We'll go down here, we're 60, 1.2, and our temperature now is at, I'd say 10.5. And it's, like I say, it doesn't want to cooperate too well with me on how it orients itself. But we can surely see now that other ice cube. You see it right there? That's the first one we put in. What have we been here? A minute, minute and a half? Try that in 20 degrees C water and see how fast the ice cube will go away. Look at how this one now. You saw the size of it when I put it in. Look at what's happened to it. Now how in the world are we causing that? And we're down to 9 Celsius now. And our electrolysis is not hindered one bit. In fact, if you look at it there, you'll see that we're more fully involved than we were. Let's see, we're running 61.2. And you can see that that ice cube, we may be able to get it to float like we want it to. Get him over here. Yeah, we got him back out of the way. Now you're going to see that accumulation of gas underneath that cube again, and the migration from the right to the left. See that going on down here? Right at the bottom. So why is this cube attracting this gas, or why is this cold water colder over here pulling these bubbles in this direction? Wouldn't you feel that the bubbles would go up and escape from the water? We're now down to 8 Celsius. And you can almost, if we watch it as steady as I can hold this camera, you can almost see it pulling that ice cube apart. I don't know. I put it up here because I found it was amazing. How did I stumble on this? Well, when no one's around the lab on weekends or holidays, the heat goes off, and I was working in the lab taking gas measurements at 17C, and I was getting very, very good results. And then when I came back in yesterday evening to do a little work, it was 22C in the lab. They were starting to warm it up for tomorrow, and lo and behold, I wasn't getting near as much gas production with the same parameters. So here's what I decided to use as a test, and here's the results.